in circular motion is the concept of radius curvature. Okay, so first let's understand what we mean by radius of curvature, and then I'll show you how to magnitude and direction of other two forces are not required. So they are out of our syllabus. It is better that we don't get into that. या मैं बता देता हूँ अभी ये रेडियस ऑफ कर्वेचर खत्म करके मैं क्विकली बता दूँ. So supposing that a particle is moving along a path and the path is साइड से मैं दिखा रहा हूँ ये, तो ये पार्टिकल है या एक ब्लॉक है या एक कार है, और वो इस तरीके से हिल वैली सिस्टम है. दिस इज द काइंड ऑफ road. This is a side view. We are not looking at it from the top. We are looking at it from the side. So this curved path can be thought of as made up of circles of varying radii. That means that we can think of this part of the path, only this part, being part of a circle like this. We can think of maybe this part of the path of being part of a circle like this. My diagrams are very, very bad. We can think of this part of the path of being part of a circle like this. Okay. So for this part then, the radius of the circle is called the radius of curvature at point whatever. So I can now say that the radius of curvature of this part of the path is R1. Similarly, on this part, radius of curvature ROC is R2 for this part of the path. Similarly, here this is radius of curvature is R3. Right, so basically any curve can be expressed, or any curve can be divided into small parts, and each part will be part of a circle. And the radius of this circle is called the radius of curvature of the path at that point. ये पिक्चर तो मैंने साइड से आपको बताया, बट ये पिक्चर अगर हम ऊपर से भी देखा, अगर ये ऐसा ऐसा पाथ पार्टिकल ने चूज किया हुआ है, तब भी अगर हम ऊपर से देख रहे हैं, if this is in the xy plane also, then also uh, the same thing will be applicable. Okay, so if I throw a projectile, let me make an axis. So if I throw a projectile follows a path like this. Now we know that this path is parabolic. ये हमें पहले से मालूम है. We know that this path is not a circle. Okay. However, what we can do is we can divide the path followed by the particle into little parts, and all these parts now, they are part of a different circle, and the radius of that circle will be the radius of curvature of that part of the path. Generally, I'm not even going to talk about radius of curvature of that part of the path. I'm just going to say the radius of curvature of a particular point on the path. Right? Because जो मैं part of the path की बात कर रहा हूँ, you have to understand that I can take it as small as I wish. So if I take an infinitesimally small part of the path, then that will look like a straight line, of course, and I can call it one point on the path of the particle. Right? So basically, the concept of radius of curvature tells us that however convoluted the path of a particle may be, at every point the particle can be thought of as moving around a different circle. Okay. Unless, of course, the particle is moving along a straight line. In that case, the radius of curvature will be infinity. So, if the particle is moving along a straight line, it is actually, or it can be thought of as moving along a circle of infinite radius. So, any path followed by the particle, however weird that path may be, every part of that path, every point on that path is associated with a circle of different radius, and that radius is called the radius of curvature at that point. This is a mathematical concept. Okay. इसमें हम फिजिक्स यूज करके हम रेडियस ऑफ कर्वेचर निकालेंगे, but this is a mathematical concept. It tells us that any graph that you draw, right? Any graph that you draw, you can take a small part of that graph. And that small part will be part of a circle, and the radius of that circle will be called the radius of curvature of the graph at that point. Okay, so how do we figure out? I'm going to change the slide. How do we figure out the radius of curvature? In fact, I won't change the slide. So finding the radius of curvature. So what you do is that you at the required point on the path of the particle, draw the tangential and the radial axis. Remember, we are going to tackle this using circular motion के concepts. सर्कुलर मोशन का पहला कॉन्सेप्ट होता है कि आपको रेडियल और टेंजेंशियल एक्सिस बनानी बनानी. So assuming that the particle is going on a curve, any curve, and I consider the motion of the particle at a particular point on the curve, and then what I do is I say that look, at this particular point the particle is actually moving along a circle of some radius. if so if so then tangential लिखा है भाई. इतनी इतनी खराब हैंड राइटिंग भी नहीं है मेरी. तो if so, if it is indeed moving along a circle, then there must be a tangential axis and a radial axis. So to draw the tangential axis is easy. Okay, for example, let me take this. Uh, projectile wala. So drawing the tangential axis is easy. You just draw the tangent to the curve at that point. So this will become the tangential axis. And to draw the radial axis, simply draw a line perpendicular, and this will become the radial axis. Okay, so wherever the particle is on the curve, you draw the tangent to the curve at that point, and you draw a line which is perpendicular to the tangent. That will give you the radial axis. Second is draw the forces or acceleration. Third, find the components of forces or acceleration. Okay, so what about the projectile? What are the forces acting here? Well, there is only one force acting here, and that is mg. Right? The projectile is under the influence of only one force, that is mg. And since I have considered the topmost point of the projectile, the tangent that I have drawn is horizontal, and the radial axis that I have drawn is vertical. And therefore, the force vector on the particle, that is mg, is exactly along my radial axis. Okay, this is very lucky. However, it may or may not necessarily be true. Now, supposing that the initial velocity of the, as usual, was v naught at an angle of theta. Step number 4, draw the velocity of the particle. So in this case, the velocity of the particle will be v naught. Right, and please notice velocity must be tangential, right? There is no other scope for this. Must be tangential. So once you have with you the tangential velocity and the radial force, okay, because you have found the components of forces. So you found the component of force along the radial axis, net force along the radial axis, or net acceleration along the radial axis, right? It's a convenient case because I am solving it. Inconvenient wala case, I'll give you in a moment. So if you know the tangential velocity and the radial forces or the radial acceleration, whatever the case may be, then what you can do is you can say that part 0. Then you can say that radial force is equal to mv square by r, and therefore r, radius of curvature, is equal to mv square, mv tangent square, divided by f. Right? And that's it. You have found the radius of curvature. Right? This is it. Here are radius of curvature. Let's find the radius of curvature for this particular guy. Okay, I'm going to change the slide. Please take a screenshot. Okay, please take a screenshot. ले लिया screenshot. हाँ, it's actually very easy. Yes, ये वाला आसान है क्योंकि मैं solve कर रहा हूँ. So F radial is equal to mg. Remember, it does not have to be mg. It can be a component of mg. It can be a component of other forces. Okay. V tangential is equal to v naught cosine theta. ये कहाँ से आया? ये कहाँ से आया? Remember that जब हम प्रोजेक्टाइल को लॉन्च करते हैं तो उसका हॉरिजॉन्टल वेलोसिटी v naught cosine theta होता है, वर्टिकल वेलोसिटी v naught sin theta होता है. तो जब वो टॉप मोस्ट पॉइंट पे पहुंचता है तो उसकी वर्टिकल वेलोसिटी 0 हो जाती है, और हॉरिजॉन्टल वेलोसिटी एक प्रोजेक्टाइल की कभी चेंज नहीं होती. राइट, रिमेंबर दिस. राइट, सो वी गेट mg. let me write the, since f radial is equal to mv tangential square by radius of curvature, we get mg is equal to mv naught square cosine square theta upon radius of curvature, and this tells me that radius of curvature v naught square cosine square theta upon. Right, this is the radius of curvature of a projectile at its topmost point. Right, and I should actually write it like this. So this is the radius of curvature of a projectile at its topmost maximum height. Find the radius of curvature of a projectile. Let's see if you remember the formulas of projectile motion. Launched with velocity v naught, angle theta, when it is at half maximum height. Yeah, chalo. So try to solve this. Follow the steps. I'll give you 5 minutes. हाँ, प्रोजेक्टाइल की वर्टिकल वेलोसिटी और उससे हमें कोई लेना देना नहीं है, हमें केवल टेंजेंशियल वेलोसिटी और रेडियल वेलोसिटी की बात करनी है। चलो अब 2 लोग हैं, प्राइस तो दिया, बाकी लोग क्या हुआ भाई, हम लोग सो तो नहीं रहे हैं? हाँ ईश्वर सो गया ना, मैं ये चेंज कर रहा हूँ changing right. So we have the projectile. It has been launched with a velocity of v naught at an angle of theta. We are asking for the radius of curvature at this point. Okay. We are asking for the radius of curvature at this point. And some information has been given about this point, and the information given is that the height is maximum height over 2, right? So the first question is, what is the speed of the particle at this point? Because the velocity of the particle will be tangential. So what is the speed of the particle at this point? That is what we want to know. कैसे निकालेंगे, याद है किसी को? Velocity of a projectile at any height magnitude of velocity is equal to under root of anybody remembers कैसे निकालेंगे? किसी को याद नहीं है? वेरी गुड, यस, vx स्क्वायर प्लस vy स्क्वायर. vx क्या होएगा और vy क्या होएगा? वेरी गुड, vx स्क्वायर plus vy square. Now the thing with vx is that it never ever changes. So this will be v naught cosine theta whole square. And the thing with vy is that it changes, but its change is that of constant acceleration minus g. So if along the y-axis the initial velocity is v naught sin theta, और अभी जब मैं बोल रहा हूँ तो थोड़ा कॉम्प्लिकेटेड लगेगा, लेकिन जो फाइनल आंसर आने वाला है बहुत ही आसान आने वाला है. So if the initial velocity along the y-axis is v naught sin theta and the acceleration along the y-axis is minus g, and the height to which the particle reaches is small h, supposing small h की वैल्यू बाद में h by 2 डाल देंगे, then I can simply use vy square is equal to uy square minus 2as plus 2as, जिसमें कि वो माइनस हो जाएगा क्योंकि a की वैल्यू माइनस g है. So I'll just write this down here. vy square is equal to uy square plus 2ay into y. याद है, ये मैंने बहुत दिन पहले ये फॉर्मूला डिस्कस किया था. uy is equal to plus v naught sin theta, it is pointing up. ay is equal to minus g, it is pointing down. And the y coordinate of the particle is h. So therefore vy is equal to v naught sin theta whole square. Okay. minus 2gh, right? And I'm saying that अगर आपको ये याद नहीं भी है तब भी ये आंसर बहुत आसान होने वाला है. So let me write Vy square here. V naught square minus 2gh. Sorry. V naught square sine square theta minus 2gh is equal to how much? ये तो बहुत ही आसान हो गया, क्योंकि यहाँ पे अगर मैं V naught square को कॉमन लूंगा तो ब्रैकेट में क्या बचेगा? ब्रैकेट में क्या बचेगा? In the bracket, I will be left with cosine square theta plus sine square theta, which is 1. So this is V naught square minus gh, right? So let's find the velocity of the particle at h by 2. So magnitude of velocity at h by 2 is equal to under root of V naught square minus 2g into h by 2. And what is capital H? याद है सबको? It is u naught square, sorry, v naught square sine square theta upon 2g. लेकिन हम तो h by 2 की बात कर रहे हैं, तो ये 4g होना चाहिए. g और g कैंसिल हो गया, 2 कैंसिल हो गया, v naught तो ब्रैकेट में बाहर आ जाएगा. क्या बचेगा मेरे पास? 1 minus sine square theta by 2. So the V here how can you use Smith a formula for H max to find the velocity? I mean, ये कैसे पॉसिबल? मतलब आप तो ये कॉन्ट्रडिक्शन इन टर्म्स हो गया ना. R इज इक्वल, अच्छा नहीं, ये कॉन्ट्रडिक्शन इन टर्म्स हो गया ना स्मिथ, क्योंकि आप बोल रहे हो फॉर्मूला फॉर एच मैक्स यूज करते हैं लेकिन निकालेंगे कुछ और. ऐसा नहीं पॉसिबल है ना. Okay. Then I need to find out. Chalo, I'll tell you what I need to find out. But pehle, let's start with the process. So the particle is here. I want to find out the radius of curvature. So what I will do is that I will draw the radial axis, sorry, the tangential axis and the radial axis. Okay, and once I've done this, I will draw the forces acting on the particle. In this case, the force acting on the particle is mg. Okay, please notice that mg does not lie along my radial axis now. This is the radial axis, this is the tangential axis. Now I know this, okay, this I have figured out, and I know this force, no problem. क्या नहीं मालूम है मेरे को? What do I need to figure out now? Can you tell me? Vijay, well done. Yes, very good. The angle, right? I need to figure out the angle. And the way to figure out an angle, whenever we are talking about a projectile motion, very, very easy to figure out the angle. Always. Okay, and how can I figure out the angle? Well, the way to do this is to realize the fact that the horizontal component of velocity always remains v naught cos theta. The horizontal component of velocity always remains v naught cos theta. So if I were to draw a horizontal line here, right, and if I were to say that, look, this angle is phi, then this would be equal to v naught cosine theta. इसमें तो कोई बहस ही नहीं है, क्योंकि horizontal component of velocity is always v naught cos theta. But since the velocity here I have assumed to be v, the horizontal component of this v must be v cosine phi. Must be v cosine phi. But this v cosine phi must be equal to v cosine phi must be equal to v naught cosine theta. So therefore v और cosine phi rather, मेरे को तो एंगल निकालना था ना, तो ये जो cosine phi होएगा that will be equal to v naught cos theta upon v. Okay? So this will be a very complicated type of an expression because v की value तो ये रही, right? और मैं उसको अभी वहाँ लिखने भी नहीं जा रहा हूँ. So if this angle is phi, okay, this angle is phi, then surely this angle is 90 minus phi, and therefore this angle must be phi. I'll just take it as phi. So let's work out the component of mg. So mg along the radial axis will be mg cosine phi. Okay. Again, let me tell you what I have done from the beginning. They have asked me to find the radius of curvature at half the maximum height. So what I did was, first I found the speed of the particle or the magnitude of the velocity of the projectile at half the maximum height. How did I do this? I wrote that the velocity of the projectile at any height must be under root of the x component of velocity square plus the y component of velocity square. The x component of velocity is always v naught cos theta, and the y component of velocity I have figured out here. Okay, I have applied v square is equal to u square plus 2s. When I do that, I get a very weird result. अच्छा हाँ, ये तो मैं बताना ही भूल गया. ये इतना आसान सा रिजल्ट क्यों आ रहा है? ओके, अगर आपको क्लास 10th का थोड़ा सा फिजिक्स याद है तो ये आसान सा रिजल्ट आपके सामने मैं लिख देता हूँ. It is change in kinetic energy is equal to change in potential energy. जब ये पार्टिकल ऊपर जा रहा है तो जितना इसका पोटेंशियल एनर्जी चेंज हो रहा है उतना ही काइनेटिक एनर्जी भी चेंज हो रहा होगा, राइट? आई मीन यही तो होता है ना कंजर्वेशन ऑफ एनर्जी. तो हाफ mv स्क्वायर माइनस हाफ mv नॉट स्क्वायर, ये इसका चेंज इन काइनेटिक एनर्जी हो गया. फाइनल काइनेटिक एनर्जी माइनस इनिशियल काइनेटिक एनर्जी, और is equal to change in potential energy which is minus mgh. ऊपर गया ना तो पोटेंशियल एनर्जी इसका जो है माइनस mgh, राइट? ओके, अगर आप इसको सॉल्व करोगे तो एग्जैक्टली यही चीज आ जाएगी. दिस इज द वे टू रिमेंबर. ओके, so what did I do? I figured out the velocity of the projectile at height h. It comes out to be this quantity. उसके बाद से what did I do? उसके बाद से what did I do? उसके बाद से I said that look, I will draw the tangential axis and the radial axis. Okay, why? Because step one वही है. At the required point, draw the tangential and radial axis. Okay. उसके बाद से once we have drawn the radial and tangential axis, then you draw. Let's see, what have I written? Draw the forces or acceleration of the particle. So I have drawn the forces acting on the particle, only one force mg. And then what are we supposed to do? Find the components of forces or acceleration. Right? Find the components of forces or acceleration. तो अब मेरे को कंपोनेंट निकालना है. तो कंपोनेंट निकालने के लिए मेरे को एंगल चाहिए. अब एंगल निकालने के लिए मैंने अज्यूम किया कि हॉरिजॉन्टल और ये v टेंजेंशियल डायरेक्शन के बीच का एंगल फाई है. राइट. अगर ऐसा है तो जो हॉरिजॉन्टल कंपोनेंट ऑफ v होएगा that should be equal to v cos phi. But the horizontal component of velocity of a projectile is always v naught cos theta. Therefore, v cos phi must be equal to v naught cos theta, and therefore cos phi must be equal to v naught cos theta by v. यहाँ तक मैंने किया है और अब मैं ये स्लाइड को चेंज करने जा रहा हूँ. मैंने mg का कंपोनेंट भी निकाल दिया. बाय द वे mg का कंपोनेंट निकाल दिया. और अब अगला स्टेप है to apply this. So I'm going to change the slide now. I'm going to go to the next slide and I'm going to write f radial is equal to mg cosine phi. Remember, cosine phi की value मेरे को पहले से मालूम है. And the velocity tangential I'm going to write v. Okay, v की value भी मेरे को मालूम. So f radial will be equal to mv tangential square upon radius of curvature. So the radius of curvature will be equal to mv tangential square upon f radial, and this will give me that radius of curvature is equal to mv square upon mg cosine phi. m और m को कैंसिल कर देते हैं और अब हम v की वैल्यू डालते हैं. ठीक है. और कोसाइन फाई की वैल्यू डालते हैं. तो पहले लेट्स लुक एट द वैल्यू ऑफ कोसाइन फाई. कोसाइन फाई इज v नॉट cos थीटा बाय v. v नॉट cos थीटा बाय v. तो ये हो जाएगा v स्क्वायर अपॉन g v नॉट cos थीटा बाय v. दिस विल बी v क्यूब अपॉन g v नॉट cosine थीटा. सो आर सी इज इक्वल टू, अब v क्यूब की वैल्यू डाल देते हैं. क्या है भाई v क्यूब की वैल्यू? वेल, v की वैल्यू तो ये है v नॉट into under root 1 minus sine square theta by 2. I just have to cube it, right? So this will be equal to v naught cube into 1 minus sine square theta by 2 whole raised to the power 3 by 2 divided by g v naught cosine theta. So the radius of curvature is v naught square by g. एक v naught cancel हो गया. Into 1 minus sine square theta by 2 whole raised to the power 3 by 2 divided by cosine theta. Ugh. Right? आया समझ में? Let's try one more. I'll write the question here only. A projectile is launched with velocity v naught, angle theta. Find radius of curvature when angle of velocity of projectile becomes theta by 2 with the horizontal. राइट अब मैं आपको क्या बोल रहा हूँ, हाफ द मैक्सिमम हाइट पे नहीं निकालना है, ओके, हाफ द मैक्सिमम हाइट पे नहीं निकालना है, हाफ एंगल जब हो जाए तब निकालना है, ओके। चलो जल्दी से करो इसको। Please follow the steps carefully as I showed you in the previous problem. आराम से carefully हाँ थोड़ा लग रहा है सही है, थोड़ा इतने लंबे लंबे आंसर नहीं होना चाहिए। पार्टिकल तो थीटा से लॉन्च तो हाफ एंगल होगा, नहीं बीच में होएगा बे। टॉप मोस्ट पॉइंट पे क्या एंगल होता है वेलोसिटी का? हाँ कर रहा है। Good. So I'm going to change the slide. This is the projectile. It was launched with a velocity v naught at an angle theta. We need to find the radius of, very good without, yes. We need to find velocity, we need to find radius of curvature when the angle made by the velocity is theta by 2. Right? Let's follow the procedure. First, Draw the radial and tangential axis. Draw the forces acting on the particle. Find the components of forces acting on the particle. Well, if this angle is theta by 2, then this angle is 90 minus theta by 2. This angle is theta by 2. So the mg wala component is mg cosine theta by 2. Okay. So we get next एक step मैं भूल रहा हूँ. I have done this. I have done this. I have done this. Ooh, velocity. Right? Velocity. V की value क्या है? This is very easy. So V cosine theta by 2, that is the horizontal component, must be equal to V naught cos theta, because the horizontal component of the velocity of the projectile always remains V naught cos theta. So the V, the speed of the particle at that point, speed of the particle at that point is V naught cos theta by cos theta by 2. And we are done now. Yeah. So F radial is equal to mg cosine theta by 2. V tangential is equal to V naught cosine theta upon cosine theta by 2. So F radial is equal to mv square upon radius of curvature. Radius of curvature is equal to mv square upon f radial, and just let's put in the values m into v square, which is equal to v naught square cos square upon cosine theta by 2 whole square, whole divided by f radial, which is mg cosine theta by 2. So this will be equal to v naught square by g into cosine square theta divided by cosine cube theta by 2. Right? And I think most of you got the answer correct. जिन्होंने किया, जिन्होंने नहीं किया, क्यों नहीं कर रहे हैं? Okay. I hope that this is, at this point, this is clear. Okay, so this is all about radius of curvature. Mathematically speaking, and I'll just put a star mark here. Star mark का मतलब don't remember. For any curve y is equal to f of x, the radius of curvature is given by a very very weird formula: 1 plus dy by dx whole square whole raised to power 3 by 2 whole upon d2y by dx square. Okay, please notice that d2y by dx square will become 0 for linear curves, and therefore the radius of curvature will be infinite for linear curves. अब ये कहाँ से आया, कैसे आया, प्लीज डोंट आस्क दिस. ये एक फॉर्मूला होता है मैथ्स में, ये मैंने बता दिया. तो अगर आपको कहीं पे किसी ने बोला y इज इक्वल टू एक्स क्यूब के लिए find the radius of curvature at x is equal to 3. So radius of curvature at x is equal to 3 will be equal to 1 plus dy by dx, which is 3x square whole square raised to power 3 by 2 upon d2y by dx square, which is 6x. And you put at x equal to 3, this will become 1 plus 20, ये हो जाएगा 3 cube is 27. 27 स्क्वायर कितना होता है? 27, हाँ, तो 1 plus 27 square raised to power 3 by 2 upon 6 into 3. So you get the direct number, radius of curvature. But you don't have to remember this. This is not in our syllabus. लेकिन अगर कहीं आपको ये सब करने का मन नहीं हो रहा है, right, then may be possible. It may become infinitely more difficult, but it may be possible that if you remember the equation of trajectory of the projectile, then finding this radius of curvature at any point may be easier like this. Okay, next is, please take a screenshot. I'm going to move to the next slide. ठीक है, आगे बढ़ रहा हूँ मैं. Next slide. So I don't think I can start work per energy today, so I'll start it tomorrow. और कल प्लीज कोई एब्सेंट मत रहना और कोई सोना मत, because it will be very very important कल. हाँ ज़ोहैब, ये मेथड अप्लाई करने के लिए फंक्शन होना चाहिए. So I was talking about the magnitude and direction of, वही परसों यार स्मिथ, मतलब भावनाओं को समझ मेरे भाई. कल की क्लास मतलब नेक्स्ट क्लास, और कल जो क्लास हो गई उसका मतलब जो पुरानी वाली क्लास. हाँ, अगर फंक्शन नहीं दिया है तो फंक्शन निकालना पड़ेगा. कोरियोलिस फोर्स का मैग्नीट्यूड और डायरेक्शन. एक्चुअली आई डोंट नीड टू गिव यू मैग्नीट्यूड एंड डायरेक्शन. आई कैन सिंपली राइट इट इन वेक्टर फॉर्म. So F is equal to minus 2m omega cross V. Right? Omega is the angular velocity of the frame of reference, and V is the velocity of the particle as seen by the observer. अभी मैंने बोला था ना कि जो रोटेटिंग ऑब्जर्वर है उसको पार्टिकल का वेलोसिटी नहीं दिखना चाहिए, क्योंकि अगर दिख गया तो ये कोरियोलिस फोर्स भी उसके ऊपर एक्ट करने लग जाएगी. इसके अलावा ऑयलर फोर्स का मैग्नीट्यूड एंड डायरेक्शन, again I'll just write it like this. This will be equal to minus mr alpha. Okay, and this is not surprising because Euler force only appears when the frame of reference is rotating. राइट. सो लेट मी जस्ट, अगर लास्ट टाइम बिल्कुल ही क्लियर नहीं हुआ था तो दिस इज एप्लीकेबल only on objects which are seen moving by non-inertial observer. Okay, and this is applicable only in frames which have angular acceleration. Okay, both the cases we are not going to get. हमारे पास अगर एक रोटेटिंग ऑब्जर्वर है तो वो रोटेटिंग ऑब्जर्वर का के हिसाब से जिस ऑब्जेक्ट का आप एफबीडी बना रहे हो वो ऑब्जेक्ट कभी मूव नहीं कर रहा है, वो ऑब्जर्वर के हिसाब से वो ऑब्जेक्ट स्टेशनरी हो. और दूसरी चीज जो आपका रोटेटिंग फ्रेम होएगा, रोटेटिंग फ्रेम ऑफ रेफरेंस होएगा, उसमें कभी भी वो फ्रेम एक्सेलरेटेड नहीं होगा, इन द सेंस कि वो एंगुलर एक्सेलरेशन नहीं होगा. राइट. अगर एंगुलर एक्सेलरेशन हुआ तो टेंजेंशियली एक फोर्स लगेगी हर ऑब्जेक्ट के ऊपर जिसकी वैल्यू रहेगी mr अल्फा. दिस इज द सेम एज नॉर्मल एक्सेलरेटेड फ्रेम्स ऑफ रेफरेंस, यहाँ पे माइनस ma स्यूडो फोर्स लगती है. एग्जैक्टली वही चीज यहाँ पे. बट अगेन लाइक आई सेड, दिस इज नॉट इन आवर सिलेबस, सो वी विल नॉट. वैसे ही हमारे जिंदगी में प्रॉब्लम्स की कमी नहीं है, तो ये सब हम अपनी प्रॉब्लम नहीं बढ़ाएंगे. अच्छा, वेट एट पोल्स वाला, हाँ मैं भूल जाता हूँ, रुको मैं बता रहा हूँ. हाँ ये मैं भूल जाता हूँ बार बार. इफेक्ट ऑफ रोटेशन ऑफ अर्थ. प्लीज सी वेरी केयरफुली. ये रहा अर्थ, ये रहा अर्थ का एक्सिस. इन रियलिटी ये एक्सिस टेढ़ा है, बट हमें कोई फर्क नहीं पड़ता है. हम बाहर से देख रहे हैं तो हम, अगर हम स्पेस से देख रहे हैं तो अप डाउन तो कोई चीज होती नहीं है. जहां भी एक्सिस है वो एक्सिस है. और ये पॉइंट अगर हम लेके चले अर्थ पे, ये वाला पॉइंट, तो इस एंगल को लैटिट्यूड बोला जाता है. राइट, बिकॉज द इक्वेटर इज 0 degrees latitude and the poles are 90 degrees latitude. Now if I were to draw an FBD for an object located at the red dot, what are the forces acting on it? Please tell me. What are the forces acting on the object located at the red dot? And we are in a rotating frame of reference, right? Earth is rotating with an angular velocity of omega. So this red guy is actually rotating in a circle like this. This is uniform circular motion. And the radius of this uniform circular motion of the red dot, okay, is equal to r cosine phi. Okay, as is obvious, ये तो r हो गया, रेडियस ऑफ अर्थ हो गया, और ये सिंपल राइट एंगल ट्रायंगल से ये येलो लाइन, येलो रेडियस का वैल्यू r cos phi आ गया. अब अगर एक ऑब्जर्वर जो नॉन इनर्शियल है वो यहाँ पे एफबीडी बनाता है तो वो बोलेगा भाई इस ऑब्जेक्ट के ऊपर अर्थ की वजह से mg फोर्स लगा है और ये mg हमेशा लोकेटेड टुवर्ड्स द सेंटर ऑफ द सर्कल होता है। इसके ऊपर एक नॉर्मल रिएक्शन लगा है क्योंकि अर्थ के सरफेस पे है तो there is some normal reaction due to the surface of the earth. Apart from this, there is a pseudo force acting on this object, and this pseudo force acting on the object must be having a magnitude which is equal to m omega square r, and it must be in a direction which is away from the circle, right? Away from the center of the circle. So we have a pseudo force which is equal to m omega square r, which is r cosine phi. This is the radius at which we are rotating at the moment. We are not rotating at the radius equal to the radius of the earth. Now this object is at rest, right? This object is at rest. So if I were to choose this axis and this axis, and if I were to find the components of this guy, ये भी एंगल फाई हो जाएगा। ये जो कंपोनेंट आएगा इसका वो आएगा m ओमेगा स्क्वायर r कोसाइन स्क्वायर फाई, और इधर जो कंपोनेंट आएगा वो आएगा m ओमेगा स्क्वायर r कोसाइन फाई साइन फाई। सो सिंस ये जो परपेंडिकुलर टू सरफेस ऑफ द अर्थ वाली डायरेक्शन है उसमें द ऑब्जेक्ट इज एट रेस्ट, I get mg is equal to n plus m omega square r cosine square phi. And this tells me that n is equal to mg minus m omega square r cosine square phi. But n, remember, is weight. Okay, n, normal reaction always measures the weight. And if normal reaction measures the weight, then I can say that this is equal to mg effective is equal to m into g minus omega square r cosine square phi. Therefore, g effective on the surface of the earth is g minus omega square r cosine square phi. Right? This is the G. So G effective is maximum at poles since phi is equal to 90 degrees and minimum at equator since phi is equal to 0 degree. बट ये FBD इनकम्प्लीट है क्योंकि इसमें दिखा रहा है कि एक फोर्स अनबैलेंस्ड है, राइट? एंड आई थिंक समबडी फिगर्ड इट आउट ऑलरेडी। ये एक फोर्स अनबैलेंस रहेगी क्या या कुछ और होएगा? ये एक फोर्स, ये वाला कंपोनेंट ऑफ फोर्स अनबैलेंस रहेगा या कुछ और होएगा? यहाँ पे देयर शुड बी ए फ्रिक्शन ड्यू टू द सरफेस ऑफ द अर्थ। यस विश्वजीत, वेरी गुड। So if I am just standing outside on the ground, is there friction acting on me? Yes, there is. What is the value of that friction? It is equal to m omega square r cos phi sin phi. Is it large? Well, I think it should be large because r is 6,400 kilometers. R, remember, is the radius of the earth. But no, it is not large because omega for the earth is very, very small. Omega is equal to 2 pi upon time period. And time period of rotation of the earth is a day. And if I were to convert that into seconds, it would be 2 pi divided by 24 into, कितना सेकेंड होता है घंटे में? 3600, 3600. So the omega would come out to be very small, and I'm going to do omega square, smaller still. So the value is very, very small, negligibly small. Sure. ठीक है. So this is effect of rotation of the earth. Next class में work energy. Please do not miss that class. Please do not sleep in that class. I will be teaching something new, and it will be used a lot of times. So you need to grasp this new concept that I will be teaching. Okay. Chalo. So I will go now. Just save. हाँ. चलो, फिर मिलते हैं अगले क्लास में. बाय बाय.